Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question paper because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for better preparation of your exam. So today, students, we will be solving JEE 2024 Shift 1 27th Jan question paper. In this particular video, I will be solving physics part of the paper. Now, starting our question paper solving series. Here we go. The first question, that is question number 31. This question says that position of an ant as in meters moving in YZ plane is given by S equals to 2t square j cap plus 5k cap where t is in second. The magnitude and direction of velocity of the ant at t equals to 1 second will be. So student, this question is directly from the chapter of kinematics. Okay. We are given with the displacement vector S equals to 2t square j cap plus 5k cap, and the magnitude and direction we have to find of the velocity at t equals to 1 second. Okay, we know that velocity equals to ds over dt. Okay, so it will be equals to d by dt of 2t square j cap plus 5k cap. So it is equals to 4t j cap plus 0. Okay. And t is given 1 second. So it will be equals to 4 j cap in positive y direction. So our correct answer is option D. 4 meter per second in y direction. Okay. Now, next question. Question number 32. This question says that given below are two statements. Statement 1, viscosity of gases is greater than that of liquid. This and second statement is surface tension of a liquid decreases due to the presence of insoluble impurities. So student, this question is from the chapter of properties of solids and liquid. So this statement 1 says that viscosity of gases is greater than that of liquid. So this statement is false as the viscosity of liquid is greater than that of gases. So this statement is wrong. And second statement is surface tension of a liquid decreases due to the presence of insoluble impurities. This statement is very correct. For example, if we take detergent surface. So in case of a detergent surface, due to the insoluble impurities, the tension decreases. So the surface tension of a liquid decreases due to the presence of insoluble impurities. So the correct answer is option B. Statement 1 is incorrect, but the statement 2 is correct. Okay. Now, next question. Question number 33. This question says that if the refractive index of the material of a prism is cot A by 2, where A is the angle of prism, then the angle of minimum deviation will be. This question is from the chapter of current electricity. Okay. So, students, the same question has been asked in JEE Mains 2022 exam. 2022 exam. The same question has been asked previously in JEE 2022 exam. According to this question, if the refractive index of prism is given as cot A by 2, we have to find the angle where A is the angle of prism, we have to find the angle of minimum deviation. So since mu is given as cot A by 2, and we know the relation that mu is equals to sine A plus del m by 2 over sine A by 2. We have to find this delta m. Delta m is the minimum deviation angle. So mu, we are given mu equals to cot A by 2 equals to sine A plus del m by 2 over sine A by 2. Now cot is what? Cos over sine. So cos A by 2 over sine A by 2 is equals to sine A plus delta m by 2 over sine A by 2. Now since sine A by 2 cancels out. So cos A by 2 is equals to sine A plus delta m by 2. Okay. Now cos A by 2 equals to sine pi by 2 minus A by 2 equals to sine A plus delta m by 2. Okay. So sine cancels. Thus pi by 2 minus A by 2 equals to A plus delta m by 2. So pi by 2 minus A by 2 minus A by 2 is equals to delta m by 2. So pi by 2 minus 2A by 2 equals to delta m by 2. So minimum deviation angle delta m is equals to pi minus 2A. So our correct answer is delta m equals to pi minus 2A. That is option A. Students, as you are seeing, the question are being repeated. Okay. So you should practice all the previous year's question paper. Now question number 34. This question says that a proton moving with a constant velocity passes through a region of space without any change in its velocity. Means the velocity is constant. There is no change in the velocity. If E and B represent the electric and magnetic field respectively, then the region of space may have. So this question is from the chapter of electromagnetic waves. Okay. Electromagnetic waves. Okay. Now, according to this question, there are given 4 statements. The first statement is if E equals to 0, B equals to 0. So students, whenever the electric field becomes 0 or magnetic field becomes 0 in a given region of space, then there will be no force. Okay, if there will be no force, then the velocity will be constant. Okay, so this statement is correct. Second one is E is 0, but B is not equals to 0. It means that if velocity is applying in this direction in the field in a given region of the magnetic field, so due to the change in magnetic field, there will be no change in the velocity. The velocity itself will remain in the constant. So option B is also correct. Option C, E is not equals to 0, but B is equals to 0. Since E is not equals to 0, therefore there is a little change in the electric field can bring a change in the force since F equals to QE, and due to this change in the force, the velocity will change. Thus, there will be no constant velocity. So this statement is wrong. And statement 4 is E is not equals to 0 and B is not equals to 0. When E is not equals to 0 and B is not equals to 0, there comes a condition where suppose force due to electric field becomes force due to the magnetic field, and due to this force, since they are equal and opposite, so the force will be, total force will remain constant, and due to this the velocity remains constant. So this statement is also true. So the correct answer is answer number ABD. ABD. Option C is correct. Okay. Now moving towards next question, question number 35. According to this question, the acceleration due to gravity on the surface of the earth is G. If the diameter of earth reduces to half of its original value and mass remains constant, then the acceleration due to gravity on the surface of the earth would be. This question is from the chapter of gravitation. Now it is saying that the acceleration due to gravity on the surface of the earth is G, means G is equals to Gm over R square. Okay. If the diameter of the earth reduces to half of its original value and mass remains constant, mass is same, okay, and diameter reduces to half of its original value. So students, if diameter changes to half of its original value, then the radius must also change to half of its original value, okay. Radius will not become r by 4. Remember, it will not become r by 4. It will be r by 2 only. So then the acceleration due to gravity on the surface of the earth would be. So from this, if mass remains constant, G is the constant. So G is directly proportional to 1 over r square. If r is changing to r by 2, so gravity will be changed to, G will be changed to 4G. Okay. So the correct option is option D, that G will be equals to 4G. Now, next question, question number 36. This question says that a train is moving with a speed of 12 meter per second on rails, which are 1.5 meter apart. To negotiate a curve radius 400 meter, the height by which the outer rail should be raised with respect to inner rail is given G equals to 10 meter per second square. This question is from the chapter Laws of Motion. So now understand this question. According to this question, there are two rails. The outer rail is in the upper side and the uh, another rail which is in the inner side. Okay. There are two rails. This is outer rail. This is inner rail. And the rail is taking a turn. A curve is making here and it starts moving on the outer rail. Okay. So the distance between them, this is h. Okay. So we have to find the value of this h. The distance between them is given b. Let us say it b. B is given as 1.5 meter. And the train is moving with a speed of 12 meter per second. Okay. This is outer rail. And this is inner rail. Since the train is moving a ton, so this Newton, this and force will be equal to the force force acting downwards mg, and will be equals to mg. So uh, resolving it into two angles, and it is making a force in the inverse direction, that is centrifugal force. When the train is taking a turn, when it is bending, it is uh, it is making a force of or centrifugal force. Okay. So this force, this theta must be equal to this theta. Okay. This theta must be equal to this theta. So this will be n cos theta and this will be n sin theta. Okay. Now, n sin theta will be equals to what? mv square over r. N sin theta is equals to this centrifugal force, mv square over r. There should be no friction between wheels and reins. When the train is taking a turn, when it is bending, there should be no friction force, no friction between the wheels and the rails. So n sine theta will be equals to mv square over r, and this n cos theta will be equals to mg. Okay, now dividing these two equation number 1 and equation number 2. When you divide these two equation, n cancel out each other. Tan theta is equals to cancel out each other. Tan theta will be equals to v square over rg. Okay, this tan theta from this diagram, see this tan theta equals to h over this b, h over b. So v square over rg is equals to h over b. So h will be equals to v square into b over rg. So v is what? 1. Sorry, v square into b na. B is 1.5 and v is train is moving with 12 meter per second speed. 12 square 144 over r. R is what? R is 400 meter and G is 10. Now solving this, we get H is equals to 5.4 centimeter. Okay. H is option B is correct. H is equals to 5.4 centimeter. Okay. Now moving towards next question. Question number 37. According to this question, which of the following circuit is reverse biased? So we have to see these four options, and from these four options, only one is the correct option. Okay? So this is from the question from the chapter of electronic devices. Okay, this question is from the chapter of electronic device. It is asking about the reverse bias. So student, you all know this is forward bias, this is P side, this is N side, this is forward bias. Forward bias means here is higher potential and here is lower potential. Okay, and reverse bias. Reverse bias means lower and higher. Okay. Now, in option A, this is 2 volt, this is grounded 0 volt. This means higher and lower. This is PN junction diode. Okay. So this is higher, this is lower. It means it is forward bias. In option B, this is 0 volt and this is -5 volt, means higher, lower. This is also forward bias. In option C, this is 2 volt, this is -10 volt, means higher, this is lower. This is also forward bias. In option 4, this is 2 volt, this is 4 volt, means lower and higher. So option D is correct. This is in reverse bias state. Okay, option D is the correct answer. Now, moving towards next question, question number 38. This question says that identify the physical quantity cannot be measured using spirometer. So, spirometer is used to measure the radius of curvature of concave lens. True. Specific, this is wrong statement. Specific rotation of liquid. Spirometer is not used to measure the specific rotation of the liquid. Thickness of thin place, true. Radius of curvature, true. So our correct answer is option B. That is, spirometer is not used to measure the specific rotation of liquid. Now, question number 39. This question says that there are two bodies of mass 4 gram and 25 gram. They are moving with equal kinetic energies. The ratio of magnitude of their linear momentum. We have to find the ratio of their linear momentum, since kinetic energy equals to P square by 2m. And this question is from the chapter of work, energy and power. Okay. Energy and power. Kinetic energy equals to P square by 2m. means kinetic energy directly proportional to P square, means P is equals to under root of kinetic energy, or we can say uh, P equals to under root of kinetic energy, or we can say like, we can say kinetic energy equals to P square by 2m. So V says that P square over 2m means P square equals to 2m into kinetic energy. Okay, we are given two masses, 4 gram and 25 gram, and they are having equal kinetic energy. If they are having equal kinetic energy, means K1 equals to K2, means P1 is square over 2M1 equals to P2 square over 2M2. 2 cancels out each other. So we have to find the ratio of their ratio of magnitude of their linear momentum, means P1 is square over P2 square equals to M1 over M2. M1 is what? 4 gram. M2 is with 25 gram. So P1 over P2 equals to under root of 4 over 25 equals to 2 over 5. So the correct answer is 2 over 5. Option C is correct. 2 ratio 5. Now question number 40. This question says that 0.08 kg air is heated at constant volume through 5 degrees Celsius. The specific heat of air at constant volume is 0.17 k calorie per kg degree Celsius, and J is equals to 4.18 joule per calorie. The change in its internal energy is approximately. It is saying that volume is constant. This question is from the chapter of thermodynamics. It is saying that volume is constant from the first law of thermodynamics. Using first law of thermodynamics. Del Q equals to del U plus del W. Since volume is constant, work done equals to PdV. Volume is constant means W equals to 0, means delta W equals to 0. So del Q equals to del U. We have to find the change in internal energy. So delta U equals to delta Q. We can write delta U as M S into delta T. M is given what? M is given 0.08 kg. So 0.08, and S is the specific heat of air is 0.17 kilocalorie per kg. So kilocalorie means 0.17 into kilo into 10 to the power 3 into calorie. Convert calorie into joule equals to 4.18 into delta T, 5 degrees Celsius into 5. So the answer is 284 joule. So change in internal energy is equals to 284 joule. So the correct option is option C, 284 joule. So our next question is question number 41. This question says that the radius of third stationary orbit of electron for Bohr's atom is r. The radius of fourth stationary orbit is. So this question is from the chapter of atomic and nuclear physics, modern physics chapter question. Okay, so according to this, if the radius of third stationary orbit is given r, so the radius of fourth stationary orbit is. As we know that the radius r is directly proportional to n square over z. Since z is same, so r is directly proportional to n square. So r1 over r2 equals to n1 square over n2 square. Okay. The third stationary orbit radius is r, means let us say r3 is equals to 3 square, and it is given capital R. So the radius of fourth stationary orbit means r4 is equals to 4 square, and we have to find the value of r dash. So r over r dash is equals to 9 over 16. Okay. So r dash is equals to 16 over 9. into R. So the correct option is option second B, 16 over 9 into R. Now next question, question number 42. This question says that a rectangular loop of length 2.5 meter and width 2 meter is placed at 60 degree to a magnetic field of 4 Tesla. The loop is removed from the field in 10 seconds. The average EMF induced in the loop during this time. We have to find the average EMF induced in the loop. So this question is from the chapter of current electricity. From the chapter of current electricity. Now, according to this question, there is a rectangular loop. Okay, there is a rectangular loop. Its length is given as 2.5 meter and width is given as 2 meter. And it is placed at 60 degree to a magnetic field. Let us say this is magnetic field B. It is given 4 Tesla and the loop is placed at an angle of 60 degree to the magnetic field. Now when the loop is removed from the field in 10 seconds, when t equals to 10 seconds, after 10 seconds the loop is removed, the average EMF, we have to find the average EMF induced in the loop. We know that the formula for average EMF is equals to change in the flux over change in the time. So change in the flux means final flux minus initial flux over delta T. So students, after T equals to 10 seconds, the loop is removed from the field in T equals to 10 seconds. When the loop is removed, at that time flux will be 0. The final flux will be 0. So we are left with initial flux over delta T. So minus minus will become plus. So initial flux over delta phi. Flux means BA cos theta over T. Okay. So B, magnetic field. Magnetic field is given as 4 Tesla. Area. Area of rectangle is length into breadth. Means length is what? 2.5 into breadth is 2 into cos theta. Cos theta means cos 60 degree 1 by 2 over time. Time is 10 seconds. After solving this, we get 4 into 2.5 into 2, 5 into 1 by 2 over 10. 2 to 10 over 10 means 1 volt. So our answer is 1 volt plus 1 volt. Okay. Now next question. Question number 43. This question says that there is an electric charge of 10 to the power minus 6 microcoulomb is placed at origin 0,0 meter of XY coordinate system. 2 points P and Q are situated at √3 meter and √6 meter respectively. The potential difference between the points P and Q. We have to find the potential differences. This question is also from the current electricity chapter. So we have to find the potential difference. According to this question, let us say at origin, let us say this is point O. At point origin, an electric charge is situated. Let us say the charge is given as 10 to the power minus 6 microcoulomb. Okay. In XY coordinate, 2 points P and Q are situated at let us say P, its coordinate is √3, √3 and Q, its coordinate are √6, 0. The potential difference between the point P and Q, we have to find the potential difference between P and Q. Okay. So now the distance of this point P from origin O will be using distance formula. What is distance formula? Under root of x minus a square plus x minus b square. X minus a square, y minus b square. Okay. So it will be x1 minus a square or x2 minus a square, same. So √3 minus 0, origin means 0, 0. It means √3 minus 0 square plus √3 minus 0 square. So it will be √6. And for the distance QO, it will be equals to √6 minus 0 square plus 0 minus 0 square. So it will be also root 6. So the distance of PO and QO are same. Since the distances are same, PO and QO root 6 and root 6. So the potential difference between P and Q will also be same. It means the difference in the potential difference will be equals to 0. So the correct answer is option C, 0 volt. Now next question, question number 44. This question says that a convex lens of focal length 40 cm forms an image of an extended source of light on photoelectric cell. A current I is produced. The lens is replaced by another convex lens having the same diameter and focal length 20 cm. The electric current now is we have to find the electric current. So as a students, we know that for the photoelectric effect, according to photoelectric effect, whenever photons fall on a metallic surface, the electrons are ejected from it. Means more intensity of the photons, more will be the ejection of the electrons, and these are the photoelectrons, and later on these photoelectrons constitute the photoelectric current. Okay, now it is saying that there is a convex lens whose focal length is 40 centimeter. Okay, and it is forming an extended image of an extended source of light on a photoelectric cell. Let us say the photons are coming like this and they are forming an image. They are focusing at a point, let us say, and its focal length is given 40 centimeter, and they are focusing at this point. Let us say if 1,000 number of photons are incident on this focal length, so the intensity of the number of electron that are ejecting from it will be 1,000. And now if the focal length is reduced to now 20 centimeter, but the diameter of the convex lens is same. So if there is another convex lens whose diameter is same to this diameter, but the focal length is reduced to 20 centimeter, then if the intensity is same, means if here also 1,000 photons are incident on this, so the number of photoelectron that are ejecting from it, they will be 1,000 only. So the current, if they are ejecting a current of 1 I ampere. So if I ampere current is produced here, so same intensity of current is also produced here. So there will be no change in the current. The photoelectric current now will be also I. So the correct option is option D, I. Now, next question, question 45. According to this question, a body of mass 1000 kg is moving horizontally with a velocity of 6 meter per second. If 200 kg extra mass is added, the final velocity is, this is from the chapter of kinematics. This is very simple question just to apply the momentum formula. According to this, the initial momentum will be equals to final momentum using conservation of momentum. Using conservation of momentum. At first, there is a mass of 1000 kg and it is moving with a speed of 6 meter per second, and after some time 200 extra mass is added to it. So initial momentum will be equals to final momentum. Initial momentum is what? M into V, means M1 V1 is equals to M2 V2. Starting at a starting point, the mass is 1000 kg and velocity is 6 meter per second. After that, 200 mass is also added to it. So 1000 plus 200 means 1200 into velocity V2. We have to find the final velocity. So V2 will be equals to 1000 into 6 divided by 1200. So it will be what? 5 meter per second. So our correct answer is option D, that is 5 meter per second. Now next question, question 46. According to this question, a plane electromagnetic wave propagating in X direction is described by. So this question is from the chapter of electromagnetic waves. Electromagnetic waves chapter. We are given an electromagnetic wave as, at first the electromagnetic wave is written as E equals to E naught sine omega t minus kx. Now comparing this equation with the given equation, so E naught will be equals to 200 volt per meter. Okay. Sine omega t minus kx. Omega will be equals to 1.5 into 10 to the power 7 and k will be equals to 0.05. Okay. Now, the question is asking about the intensity of the wave. So the formula for the intensity of wave is equals to 1 by 2 C epsilon naught E naught square. Okay. So it will be equals to 1 by 2 C. Since omega equals to Ck, therefore C will be equals to omega by K. So omega value 1.5 into 10 to the power 7 over K is 0.05. Solving it, we get 3 into 10 to the power 8. Okay. So put the value of C here, 3 into 10 to the power 8 into epsilon naught. Epsilon naught value is given as 8.85 into 10 to the power minus 12. 8.85 into 10 to the power minus 12. And E naught square. E naught square is 200. Means 200 square means 200 whole square. So solving this, we get I is equals to 1 by 2 into 3 into 10 to the power 8 minus 12 into 8.85 into 2 to 4 into 10 raised to the power 4 means plus 4. So it will be equals to 3 to 6 into 8.85 into 10 raised to the power 8, 0 means 1. So it will be equals to 53.1. Okay. So I intensity is 53.1 Weber per meter square. So the correct answer is 53.1 Weber per meter square, option B. Next question, question number 47. This question says that there are two statements. Statement 1 says that Planck's constant and angular momentum have same dimension. And second statement is linear momentum and moment of force have same dimension. So this question is from the chapter of unit and measurement. Chapter number 1, unit and measurements. So statement 1, according to statement 1, Planck's constant and angular momentum have same dimension. From the Bohr's quantization formula, mvr equals to nh over 2 pi. Electron can revolve only in those orbits whose angular momentum is equals to an integral multiple of nh over 2 pi. Now, this is from the Bohr's quantization formula. So since n and 2 pi are constant, so h will be mvr. So dimension of h, since energy stored of an orbit E equals to h into nu means velocity hv, h equals to E upon v. So we can write h is as E upon v. Okay. So E, dimension of E, h equals to E upon v. Dimension of E is m L square t minus 2, and velocity, dimension of velocity is L t minus 1. So dimension of h will be m L t minus 1. Dimension of h will be m L t minus 1. Now dimension of what? mvr. Dimension of mvr. M VLT minus 1 RL. Okay, so dimension of what? Sorry, it is L cube. Yeah, this will be L square, LT minus 1. So the MVR will be M L square T minus 1. So dimension of H and MVR are same. Okay. Now, second statement is what? The linear momentum and momentum of force. Linear momentum is P equals to mv. Its dimension is mlt minus 1. And moment of force means torque. Torque means R cross F. It will be equals to L into ml square mlt minus 2. So it will be equals to ml square t minus 2. So these two are not equal, means statement second is wrong. So the correct answer is answer 1, that is statement 1 is true but statement 2 is false. Okay. Now moving towards next question, question number 48. This question says that a wire of length 10 centimeter and radius root 7 into 10 to the power minus 4 meter connected across the right gap of a meter bridge. When a resistance of 4.5 ohm is up connected on the left gap by using a resistant box, the balance length is found to be at 60 centimeter from the left end. The resistivity of the wire is, since at the left gap, okay, at the left gap the resistance is 4.5 ohm and the balance length is 60 centimeter. So for the null point, if we talking about the null point, for the null point 4.5 over 60 remaining will be 40, it will be equals to this what, r over 40. So here from here we get r equals to 4.5 into 40 over 60. It will be equals to uh 1.5 into 2 means 3. R is 3 ohm and resistivity rho equals to RA over L. So it will be equals to 3 into area. Area is given as what? Area will be our pi r square means 22 by 7 into r square. R is root 7 into 10 to the power minus 4 means 7 into 10 to the power minus 8 over L. Length is given 10 centimeter means 10 into 10 to the power minus 2 meters. So solving it, we get rho resistivity as 66 into 10 to the power minus 7 ohm meter. So comparing it with the given, so R value of R is 66. Okay. Now next question, question number 49. This question says that a wire of resistance R and length is cut into 5 equal parts. Resistance R and length L is cut into 5 equal parts. If these parts are joined parallelly, then the resultant resistance will be, we have to find the resultant resistance. This question is from the, also from the chapter of electronic devices. No, this is from the chapter of current electricity. This is from the chapter of current electricity. If the length is L and resistance is R, it is cut into 5 equal parts. So then resistance of each part will be equals to R by 5. And since they are joined parallelly, so total resistance will become 1 by 5 into R by 5. It will be equals to R over 25. Now next question. Question number 50. This question says that the average kinetic energy of a monoatomic molecule is 0.414 electron volt at temperature. This question is from the kinetic theory of gases. Kinetic theory of gases. We have to find the average kinetic energy is given this, and we have to find the value of temperature. For a monoatomic molecule, the average kinetic energy is equals to 3 by 2 kBT. Since kinetic energy is directly proportional to n by 2 kBT, this n for monoatomic molecule, this n is equals to 3. For monoatomic molecule, this n is equals to 3. For diatomic molecule, this n is equals to 5. Okay, for diatomic. So Kinetic energy will be for monoatomic molecule 3/2 kBT. There, since the kinetic energy is direct, so we have to find the temperature, na? So temperature will be equals to 2 into kinetic energy over 3 into kb. So 2 into kinetic energy is given as 0.414 electron volt. Convert this electron volt into joule. 1.6 into 10 to the power minus 19 over 3 into kb. Kb is the Boltzmann constant. Its value is 1.38 into 10 to the power minus 23 joule per Kelvin. Solving this, we get T is equals to 3200 Kelvin. So T will be equals to 3200 Kelvin. So our correct answer is option B. So now moving on towards question number 51. This question says that a particle starts from origin at t equals to 0 with a velocity 5 iota meter per second and moves in xy plane under action of force, which produces a constant acceleration of 3 iota plus 2 j cap meter per second square. If the x coordinate of the particle at that instant is 84 meter, then the speed of the particle at this time is under root alpha meter per second. We have to find the value of alpha. So student, this question is from the chapter of kinematics. According to this question, we are given the initial velocity, means at time t equals to 0, the velocity, initial velocity, let us ux is equals to 5 meter per second. Okay, it is in xy plane and and it produces a constant acceleration of 3 iota cap plus 2 j cap meter per second. So acceleration ax equals to 3 meter per second square. So, and x is given as 84 meter. Okay. So, using equations, that is v square minus ux square, third equation of motion, vx is v square minus u square equals to 2ax. So, v for initial velocity, vx square minus ux square equals to 2ax. So, vx square minus ux square 5 square equals to 2 into acceleration 3 into x 84. So vx square is equals to 2 into 3 6 into 84 minus 5 5 square 25 plus this will be added na. So vx square will be equals to 4 carry 2 504 plus 25, it is equals to 9529. So vx square equals to under root of 529, it will be equals to, so vx will be equals to 23, okay, meter per second. Now from the first equation of motion, vx minus ux equals to axt. So t will be equals to Vx minus Ux over Ax. It will be equal to 23 minus 5 over Ax3. It will be equals to 6 second. Okay. So Vy will be equals to 0 plus Ayt. It will be equals to 0 plus Ay 2 into T 6. So it will be equals to 12 meter per second. Now the final velocity v square equals to vx square plus vy square. So it will be equals to 23 square plus 12 square. It will be equals to 673. So v is equals to under root of 673 meter per second. So our final velocity, resultant velocity is under root of 673 meter per second. So the value of alpha is equals to 673. Got it? Again, I'll repeat this question. According to this question, initially when t equals to 0, the velocity is given as 5 iota meter per second. Means at t equals to 0, the initial velocity ux equals to 5 meter per second. At that time, acceleration a is given as 3 iota plus 2j meter per second square. Means this is along x, this is y. Okay, so ax will be equals to 3 meter per second and x is given as 84. Using third equation of motion, vx square minus ux square equals to 2ax. From this we find the value of vx. Vx comes out to be 23 meter per second. Now v minus u equals to 80. V minus u equals to 80. So from this we find the value of t, that is 6 seconds. Okay. Now Vy equals, for y coordinate, Vy equals to, Vy will be equals to uy plus ayt na. So uy to is 0. So we get Vy equals to ayt. Ay acceleration for y, it is 2. So we write 2 into time is what? 6 seconds. So we get Vy equals to 12 meter per second. Now the resultant velocity v square equals to vx square plus vy square. So we get the resultant velocity v as under root of 673 meter per second. So the value of alpha is 673. Okay. Now next question, question number 52. This question says that a thin metallic wire having cross-sectional area of 10 to the power minus 4 meters square is used to make a ring of radius 30 centimeter. A positive charge of 2 pi c is 2 pi coulomb is uniformly distributed over the ring, while another positive charge of 30 picocoulomb is kept at the center of the ring. The tension in the ring is dash Newton. We have to find the tension. Okay. This question is from the chapter of electrostatics. According to this question, there is a ring, okay, and its cross-sectional area is given as 10 to the power minus 4 meter square, and the radius of the ring is given as 30 centimeter, okay. A positive charge of 2 pi coulomb is uniformly distributed over the ring. Let us say Q naught charge is distributed over the ring, and this Q naught equals to 2 pi, okay. And at the center of the ring, another charge is at the center of the ring, 30 picocoulomb. Let at the center is charge Q, say. So this Q will be equals to 30 picocoulomb is kept at the center of the ring. The tension in the ring, let us say this is making a small angle. Suppose this tension T is acting in this direction and another tension T is acting in this direction, and force Fe is in the upward direction. So considering this d theta as the small element, we can write for a ring 2t sine d theta by 2 equals to k q naught over r square lambda r d theta. Okay. Now this lambda, linear charge density, equals to charge over line element, that is circumference of this ring, 2 pi r. So putting this value and considering this d theta as the small angle, we write T is equals to k q naught into q over r square into 2 pi. By putting the value of lambda here and considering this theta angle as a very small angle, so sine d theta by 2 will be approximately equals to d theta by 2. Okay. Now, so t becomes k q naught q over r square into t 2 pi. Now, putting the value of k, that is 9 into 10 to the power 9 into q, 2 pi into q, 30 picocoulomb, yani 30 into 10 to the power minus 12 over r square. R is what? 30 centimeter. Radius is 30 centimeter, means 30, 0.30 whole square into 2 pi. So the tension T is equals to 9 into 10 to the power minus 3. This 2 pi cancels out each other into 30 over 9 into 10 to the power minus 2. So 9 cancels out each other. It will become 30 into 10 to the power minus 3 plus 2. It is equals to 30 into 10 to the power minus 1. So T will be equals to 3 Newton. So the tension in the ring is 3 Newton. Okay. Now next question. Question number 53. This question says that two coils have mutual inductance 0.002 Henry. The current changes in the first coil accordingly to the relation I equals to I naught sin omega t, where I naught is 5 ampere and omega is 50 pi radian per second. The maximum value of EMF in the second coil is pi over alpha V. We have to find the value of alpha. This question is from the chapter of electromagnetic induction and alternating current. Electromagnetic induction and alternating current. Okay. So according to this question, there are two coils, 1 and 2. Suppose current is flowing in coil 1 and this current is equals to I naught sine omega t. Due to this current flowing in coil 1 and EMF is generated in coil 2, and this EMF E is equals to minus del phi over del t. Okay, taking only the magnitude, E will be equals to d phi over dt and phi is equals to m into I. Okay, so E will be equals to m di over dt. It will be equals to m d by dt of I. I is what? I naught sine omega t. Now differentiating this I naught sine omega t, we get EMF is equals to m I naught omega cos omega t. Okay. Now putting the value of this, the EMF will be maximum when cos omega t will be maximum. So EMF E will be equals to m I naught into omega. Okay, and the maximum value of cos omega t is 1. So maximum EMF equals to m I naught omega. M is given as what? 0.002 Henry. It will be equals to 0.002 Henry into I naught. Current is given as 5 ampere and omega is 50 pi radian per second. Current is given as 5 ampere and omega 50 pi radian per second. Solving this, we get uh, 2 over this 1000 into 5525 into 10 pi. So we get 25 into 250 over 1000 into 10 into pi 52. So we get E maximum equals to pi by 2 volt. So EMF is equals to pi by 2 volt. Now comparing it with the given answer, pi over alpha volt. So the value of alpha is equals to 2. Okay. This is our final answer. Now next question, question number 54. This question says that two immiscible liquids of refractive indices 8 by 5 and 3 by 2 respectively are put in a beaker as shown in the figure. The height of each column is 6 centimeter. A coin is placed at the bottom of the beaker. For near normal vision, the apparent depth of the coil is alpha over 4 centimeter. We have to find the value of alpha. So the formula for apparent depth, H apparent is equals to H1 over mu1 plus H2 over mu2. So H1 is what? 6 centimeter over mu1 is 3 by 2 plus H2 is also 6 centimeter over mu2 is 8 by 5. So it will be equals to 6 over 3 into 2 plus 6 over 8 into 5. It will be 12 over 3 plus 30 over 8. So it will be equals to 4 to 4 into 15. So it will be equals to 4 plus 15 over 4. It will be equals to 16 plus 15 over 4. It will be equals to 6, 5, 11, 31 over 4 centimeters. So H apparent depth of the coin will be 31 by 4 centimeter. By comparing it with the equation alpha over 4 centimeter, we get alpha equals to 31. Now, next question, question number 55. This question says that in a nuclear fission process, a high mass nuclide with binding energy 7.6 mega electron volt per nucleon dissociated into middle class nuclide having binding energy of 8.6 mega electron volt per nucleon. The energy released in the process would be, we have to find the released energy. So this question is from the chapter of atomic and nuclei. According to this question, a nuclear fission process is taking place and this is breaking up into two equal parts. So the energy released in this process is equals to binding energy of the product minus binding energy of the reactant. Since we are given binding energy per nucleon, na, the mass of this nuclide is 236 and the masses of these are 118 and 118. Mass number A equals to 118 and A equals to 118. Okay. Now this is having binding energy per nucleon as 7.6 and these two are having binding energy per nucleon as 8.6. So if we want to find the binding energy of this, so binding energy will be equals to this 7.6 into A. So Q energy released will be binding energy of product means 236 into 7.6 minus into 2. Okay, since these are two nuclides na and into binding energy of reactant. Sorry, 8.6. Sorry, this will be equals to of product na. So Q will be equals to 2 into 118 into 8.6 minus of reactant. Reactant will be 236 into 7.6. So it will be equals to 8 to 16 carry 1, 213, 212, 236 into 8.6 minus 236 into 7.6. Taking this 236 common, we get 236, 8.6 minus 7.6. So it will be equals to 236 into 1. It will be equals to 236 mega electron volt. Okay. So our answer is 236 mega electron volt. Now next question, question number 56. This question says that there are 4 particles, each of mass 1 kg are placed at 4 corners of a square of side 2 meter. The moment of inertia of the system about an axis perpendicular to its plane and passing through one of its vertex is. We have to find the moment of inertia passing through one of its vertex. So this question is from the chapter of rotational motion. Rotational motion. According to this question, there is a square and each corner having a mass m of 1 kg. Okay. Let us say we have to find the moment of inertia of the system about an axis perpendicular to plane and passing through one of its vertex. Let this vertex be this. So according to question, if the moment of inertia is passing through this vertex and about this, the moment of inertia I will be equals to 0. So from these 3 corners, the total moment of inertia, if the side is, let us say A, A. So this distance will be root 2A. So for this, the moment of inertia will become mi equals to m into a square plus m into a square plus m into, for this, root 2 a square. So this will be equals to 2ma square plus 2ma square. Okay, so this will be equals to 3ma square, na? This 2, sorry, 4ma square. 2 plus 2, 4ma square, okay? So it will be equals to 4, mass is 1 into A. Area is given side of 2 meter, means 2 square. So it will be equals to 16. The moment of inertia Mi is 16. Okay, now next question. A particle executes simple harmonic motion with an amplitude of 4 centimeter. At the mean position, the velocity of particle is 10 centimeter. The distance of the particle from the mean position when its speed becomes 5 centimeter per second is under root of alpha centimeter. So we have to find the value of alpha. This question is from the chapter of oscillation and waves. Oscillation and waves. According to this question, a particle is performing simple harmonic motion and its amplitude is 4 centimeter. Let us say this is the mean position. About this mean position, its velocity is 10 centimeter per second. And after some distance, its velocity becomes, let us say, for this position, its velocity becomes 5 centimeter per second. We have to find this distance x. Okay, let us say the velocity at the mean position. Velocity at the mean position will be equals to a into omega. Okay, this is equals to what? 10, given 10 centimeter per second. So and a amplitude is given 4 centimeter. So 4 into omega equals to 10. So omega will be equals to 10 by 4 equals to 5 by 2. So V will be equals to omega. There is a formula for this, a square minus x square. So V is what? 5 centimeter per second. So 5 equals to omega 5 by 2 into under root of a square, means 4 square minus x square. So squaring both sides, we get 25 equals to 25 over 4 into 4 square minus x square. So 25 cancels out each other. So 4 will be equals to 4 square minus x square. So x square will be equals to 16 minus 4. X square equals to 12. So x will be equals to under root of 12 centimeter. Okay, so the value of this alpha is 12. Now next question, question number 58. This question says that there are two long straight wires carrying equal currents in opposite directions as shown in the figure. The separation between the wires is 5.0 centimeter. The magnitude of the magnetic field at a point P midway between the wires is, we have to find the magnetic field. So this question is from the chapter of magnetic effects of current and magnetism. Magnetic effects of current and magnetism. Okay, according to this question, there are two wires. This is carrying a current of 10 ampere and there is another wire and this is a carrying current of 10 ampere and the direction of current in both the wires are opposite and here is a point P. The distance between the wires is 5 centimeter. So the distance from one wire will be 5 by 2 centimeter. Okay. Now we have to find the magnetic field. The magnetic field because of these two wires will be, if we find the magnetic field from of one wire, then we multiply it by 2. Okay. So 2 into, for one wire it will be equals to mu naught I over 2 pi a. So 2 cancels out each other. It is equals to mu naught I over pi a. Mu naught is what? 4 pi into 10 to the power minus 7. 4 pi into 10 to the power minus 7. I is 10 ampere over pi into A. A is what? This distance, 5 by 2. So 5 by 2 centimeter means 5 by 2 into 10 to the power minus 2. Now solving it, pi cancels out each other. This will be 4 into 2, 8 into 10 minus 7 plus 1 over 5 into 10 to the power minus 2. Now solving it, we get 160 micro Tesla. Okay. So magnetic field will be 160 micro Tesla. It will be 160. Now next question. This question says that the charge accumulated on the capacitor connected in the following circuit is. We have to find the charge. This capacitor is given C, capacitance 150 microfarad. This question is from the chapter of electrostatics. Now, if we see this figure can be transformed as, or we can make this figure like this. This will be like this. Like this, okay? This will be 6 ohm. This will be 4 ohm. This will be 1 ohm. And this will be 2 ohm, okay? Now, this is our capacitor C. We have to find the charge accumulated on the capacitor, okay? Now this is connected to a battery of what? 10 volt. This is connected to a battery of 10 volt, okay? 10 volt. So for this, for these two, 6 ohm and 4 ohm, the current flowing through this will be I equals to 1 ampere. From Ohm's law, since V equals to IR, so I will be equals to V over R. V is 10 volt over R. R is 6, 4, 10. So I will be equals to 1 ampere. For this, the current flowing through this will be 1 ampere, okay? Current flowing this through will be 1 ampere. And current flowing this through this will be I is equals to 10 by 3 ampere. How? Again using Ohm's law, V equals to IR, I equals to V over R. V is what? 3, V over R. V is what? 10 over R is 2 plus 1, 2 plus 1, 3. So current flowing through this is what? 10 over 3 ampere. Okay. Now, let us say here is voltage 10, here voltage is 0. Potential difference between them is 10. Na? So here potential 10, here is 0. So if here is 10, so here also is 10. Now if 10 voltage is going through this arm, so if this here the potential across this resistor will be 6 volt. So at this point, if the potential is 10 volt, so at this point the potential must be 4 ohm. So 10 minus 4 will be 6. This 6, how this 6 came? Again using the Ohm's law, since V equals to IR. I is what? 1. R is what? 6 ohm. So V will be 6 volt, na? So the voltage across this resistor 6 ohm will be 6 volt. At this point the potential is 10 volt. At this point potential is 4 ohm. Again, if at this point the potential is 10 volt, so using the same Ohm's law, at this point the potential is what? V equals to IR. In this branch, I is 10 by 3 and R is 1. So we will be at this point what? V equals to IR. Voltage will be 10 by 3. Okay. Now solving this, we get, so across this resistor, the voltage will be 10 by 3. If across the resistor voltage is 10 by 3, so at this point it will be 20 by 3. Okay. So the difference will come 10 by 3. Okay. So at this point, let this point be A and let this point be B. At point A, the voltage is 4 volt, and at point B, the voltage is 20 by 3 volt. Okay. So the potential difference between A and B, potential difference is what? 20 by 3 minus 4 volt, it will be equals to 8 by 3 volt. Okay. If the potential difference is 8 by 3 volt, then the charge passing through this capacitor, potential difference between this A and this point B is 8 by 3 volt, then the charge passing through this capacitor C, Q equals to C into V. So C is what? Capacitance is given as 150 microfarad and voltage is 8 by 3. So 8 by 3 into 150 microfarad. So it will be equals to 400 microcoulomb. So our answer is 400 microcoulomb. Okay. Now the next question, question number 60. This question says that if average depth of an ocean is 4,000 meter and the bulk modulus of water is this 2 into 10 to the power 9 Newton per meter square, then frictional compression delta V over V of the water at the bottom of ocean is alpha into 10 to the power minus 2. We have to find the value of alpha. This question is from the chapter of properties of solids and liquids. Properties of solids and liquid. According to this, B is equals to minus delta P over del V over V. Means bulk modulus is equals to minus of delta P over this fractional compression. So the fractional compression becomes delta V equals to V. Minus of delta V over V equals to delta P over V. So this delta P equals to rho GH over B bulk modulus. It will be equals to density 1000, gravity 10 into H. H is given as 4000 meter over B. Bulk modulus is given as 2 into 10 to the power 9. So solving this, we get delta minus of delta V over V fractional compression as 2 into 10 to the power minus 2. So comparing it with the given equation equals to alpha into 10 to the power minus 2, we get the value of alpha as 2. This negative sign represents the compression. This negative sign, it represents the compression. So alpha is equals to 2. This is our final answer.